Hi guys! Alright, today's going to be Unit 1, Day A, where we're going to solve absolute value equations and other types of equations, okay? So let's do a little review really quick about absolute values. So if I had an absolute value of x, and let's just say it's positive 21, we need to understand that there's two ways, right, what x can be. X could technically be a positive 21, because absolute value of a positive 21 is still 21, or x could have been negative 21, because, right, negative 21 in absolute value is going to still give us that positive. So we're going to have these two solutions, and we need to make sure to check that they're not extraneous. So let's just jump in right into problems. So first off, we got some directions. Let's solve for all real solutions, and we'll do exact or approximate depending on the problem. So let's just jump into example 1 and say the absolute value of 3x minus 1 is equal to 8. So the same thing. This is going to split into the positive one. So I'm going to rewrite the inside, and it's equal to the positive 8. Or the inside can be equal to a negative 8. And we solve these guys. So adding 1, dividing by 3. And then same thing on the right side, adding 1, dividing by 3, so negative 7/3, okay? Plugging this back in for the x spot, I realize that the left side does equal 8, okay? Technically, I could have solved this by graphing, okay? So first step for graphing is to make sure you tell your teacher exactly what did you plug into your calculator. So in y sub 1, I plugged in the left. Y sub 2, I plugged in the right. Again, I don't like to manipulate it and set it equal to 0. If you do, you're welcome to do that. Step 2 is to actually graph it out, a nice sketch. So the first part, here's my absolute value one. Put arrows. I'll say the y equals 8 is about here. Arrows on those guys. And then we have our intersections. And then of course, obviously you're going to give us the answers, which we had written down. Okay. So let's try the second example. 2 absolute value of x plus 4 minus 3 is equal to 7. Okay, so first thing, our goal is to get the absolute value by itself before we split into the positive and negative like I did above. So let's get rid of that 3 by adding it. Let's get rid of the 2 by dividing both sides by 2. And now we go to our split. So the x plus 3 can equal a positive 5. I don't know where that 3 came from, guys. Hopefully you didn't write that 3 down. There we go. So we're going to subtract to get a 1. And then x plus 4 is equal to the negative of it. So negative 5, subtract negative 9. Okay? I did check these. I did plug it in, and the left side, when I plugged in a 1, does equal a 7, and when I plugged in a negative 9, it also equaled to 7, okay? So no extraneous. Both of these are my answers. Again, you can verify it by graphing, and you realize those are the two answers you should be getting. Remember, graphing doesn't show extraneous answers. That takes us into example 3. Let's pick it up a little bit. So we have x squared minus 3x, that's an absolute value, is equal to a negative 4x plus 6. Well, the absolute value is already by itself, so we can actually go into the splitting point, and we have x squared minus 3x is equal to, be careful here, the positive of the right side. So at this step, let's actually solve. So nothing changes on the right side, so negative 4x plus 6 when I distribute. Let's get it all equal to 0. So let's add 4x and subtract 6. So x squared plus x minus 6 is equal to 0. I'm going to try and factor this. Trinomial should be hopefully nice. We have an x. I'm going to go 3 and 2 because I realize the middle term is a 1. Positive 1, so a positive 3 and a negative 2. 0 product property, so x is equal to a negative 3 and a positive 2. Okay, then I'm going to do the negative side. So keep the left side the same, the stuff that's inside the absolute value. The negative of the right side, so negative 4x plus 6. Let's clean up and distribute the right side. So x squared minus 3x is equal to a 4x minus 6. Let's get this guy set equal to 0. So subtract a 4x, add a 6. So x squared minus 7x plus 6 equals 0. Factor him out. I have an x and an x. So I want a negative 7 in the middle. So I'm going to probably use a 1 and a 6. Both negative. 0 product property. X is equal to 1. And x is equal to 6. I am going to check, are any of these extraneous? So if I pull up the calculator, and let's now do it like this. There we go. And clear, let's go second quit. Okay, so the first value was a negative 3, so I'm going to go negative 3 stow x. I stored in that value for the x, and now I'm literally going to just write exactly what I see. So absolute value x squared minus 3x, enter, get the value of 18. Then I'm going to check the right side, so negative 4x plus 6, 18. Okay, so negative 3 passed. So now I'm going to stow the value of 2 for x, copy the same thing and check. Let's go absolute value, let's plug in x squared minus 3x, value is 2. Let's check the right side, negative 4x plus 6, ooh, negative 2. So this guy actually fails, so we cross them out. Let's stow 1 and check if 1 passes. So x squared minus 3x is a 2, negative 4x plus 6 is a 2, so that one passes. So let's stow 6 and check, does that one pass, our last one. X squared minus 3x, 18, and negative 4x plus 6. Ooh, negative 18. So that one fails. Those are our extraneous ones. So again, make sure you write just the ones that we want. So x is negative 3 and x is 1. Again, if you graphed it, you're going to see that that is exactly where they have an intersection. Okay, so that takes us then into example 4. And I have x to the 4th minus x cubed plus 5x squared is equal to 6. Alright, so if I had 4 terms, right, in my head I'm thinking, alright, I can probably go by grouping, so let me just check here. X to the 4th minus x cubed plus 5x squared minus 6 equals 0. I'd really quickly draw in these parentheses and start taking out a GCF. So I'd be doing like x cubed, so an x minus 1 is left, and then I don't even have a GCF on the other one, so I'm realizing right away that the two binomials would not be the same. So unfortunately, factoring doesn't work, right? So what am I going to do? I'm going to just graph this then, right? So this one, we're going to write can't solve algebraically. And sometimes that happens. You got to go by calc. So I'm going to clear this guy out. And let's type in, guys. Let's graph this in. X to the 4th minus x cubed plus 5x squared. Oh boy. Let's delete that. There we go. Plus 5x squared. Okay, and then it was equal to 6, so I'm going to put that in y sub 2. Graph that guy. And wondering, there we go. So I want their intersection. Second calc, 5, enter, enter, and I'm going to go to the 100th for these. So x equals negative 0.94. And then I'm going to find the other intersection. So second trace 5, enter, enter, and I got it about 1.09. And I got both of our solutions. Again, sometimes you can't go algebraically, so you got to go graphing, okay? So for this, I'm going to make sure I tell my teacher that the way I graphed it was putting the left side into y sub 1, the right side was the y sub 2, and of course I'm going to sketch it out best of my ability so my teacher sees where the intersections are happening. That's how you show your work when you're graphing. Alright, well, let's just do one more then. Example 5. Let's change it up a little bit. Let's get some trig happening up in here. So we got some sine, and let's say it's equal to x cubed. Well, for this one, I'm thinking we should go by calculator because we don't know how to factor anything with sine, or how do we solve, right, with sine. So let's let our calculator do it. The most missed question here, though, is, and people forget, but it's like, what mode am I supposed to be in? Well, guys, if you don't see any degree symbol in there, you're going to be in radians. So I'm going to check. Yes, I'm in radians. Good. So let's graph this guy. Clear those out, and let's hit sine of x. And the other one is just x cubed. and graph. So again, my step 1 is to tell my teacher how did I graph it in my calculator. So sine of x, y sub 2 was x cubed. Then I'm going to do a nice graph sketch, right? So I'm going to zoom in. I'm going to just picture that guy in here. So we have y and x-axis. Sine goes through the origin. Put my arrows, and then I'm going to draw in my cubed. Alright, then we have some intersections. Make those noticeable. Let's actually find what they are. So it looks like we have 3. So I'm just going to write those out. And second, trace 5. Let's find the most right one. So that's about, again, let's round that. So 0.93. Then I'm going to do the middle one. So we have a 0. And then let's do the left one. So that's -0.93. And we have all 3 answers then. And that's it, right? Alright guys, that is the end of day 8. Going over absolute values. Make sure if you have questions to ask the following day, make sure you're advocating for yourself, make sure you're figuring out what's a good schedule. Keep up the great work, keep advocating for yourselves. Very proud of you. Alright, I'll see you tomorrow.